Hey guys, Rhea here. Today we're going to look at this short question that focuses on differentiation, and it's quite a nice question to pick up your marks in, so let's get straight into it. So in part A of the question, they want you to differentiate the function from first principles. So the first thing you need to do is write down your formula. So here's your formula that you're going to be using, and it's really important that you learn this formula off by heart for the exam because it's not in the formula tables book. So the first thing I'm going to do is I'm going to write out what f of x plus h is. So to do that, I'm going to go to the original function, and anywhere we have an x, I'm going to replace it with x plus h. So now I'm just going to go ahead and multiply this out. So squaring out the brackets, square the first term and get x squared, square the second term and get h squared, multiplying the first term by the second term and doubling it, we'll get 2xh minus 7x minus 7h minus 10. So now we can go ahead and figure out what f of x plus h minus f of x is. So now I'm going to rewrite this line, and this time I'm going to take into account this minus sign here. So that'll leave us with minus x squared plus 7x plus 10. And so a really good indicator that you're going right in this question is that a lot of your terms should cancel at this part. So this x squared will cancel with this minus x squared, this minus 7x will cancel with this plus 7x, and this minus 10 will cancel with this plus 10. So now we can go ahead and find out what our fraction part of our formula is. So I'm going to go ahead and sub that in. So now this is what we're left with, and we need to divide the numerator by h. So dividing h squared by h will just leave us with h, and these two h's are going to cancel, so that'll be plus 2x minus 7. So now the last thing to do is we need to apply the limit to this part here. So applying the limit basically means anywhere we have a h, we're going to replace it with 0, so that'll be 0 plus 2x minus 7, which will leave us with 2x minus 7. So this is your answer to the first part of the question, and to get that answer you get a total of 10 marks. In part B of the question, they give you the function g of x, which is this fraction here, this algebraic fraction, and they want you to find the derivative of g of x when x is equal to minus 2. So because we're dealing with an algebraic fraction, we're going to have to go to page 25 of the Formula and Tables book to use the quotient rule. So here's page 25, and you can see that the quotient rule is located in the middle of the page, so this is what we're going to use for this part of the question. So now that we have our formula, to start subbing in, we need to figure out what some of our terms are first. So first of all, if we try and figure out what du dx is, so looking at our fraction, our numerator is going to be u and our denominator is going to be v. So du dx is going to be differentiating our numerator, and differentiating 6x plus 1 will just leave us with 6 because we drop the x and then our constant goes to 0. So now we need to figure out what dv dx is, so we're going to be differentiating the denominator. So differentiating x to the 4 will give us 4x cubed, and then we lose our plus 3. So now we can go ahead and sub that into the formula. So this is what you should be left with when you sub into the formula. So now the next thing to do is to multiply out this fraction here. So when you multiply out your fraction, you should be left with 6x to the 4 plus 18 minus 24x to the 4 minus 4x to the power of 3 all over x to the power of 4 plus 3, all to be squared. So now we can go ahead and tidy this up. So 6x to the 4 minus 24x to the 4 will give us minus 18 x to the power of 4 plus 18 minus 4x to the 3 all over, and we're just going to keep our denominator the same, so that'll be x to the power of 4 plus 3 all to be squared. So now we don't want g dash of x, we want g dash of minus 2. So now I'm going to look at this part of the formula here, and anywhere we have an x, I'm going to replace it with minus 2. So now all I'm going to do is I'm going to put this entire fraction into my calculator, and we should get our answer. So putting that all into the calculator, we should get an answer of minus 238 all over 361. So this is your answer to this part of the question, and to get that answer, you get a total of 10 marks. In part C of the question, they tell you that the graph h of x has a local minimum at the point 0, 5, and they want you to state whether the value of h of x must be at least 5 for all real values of x. So the first thing I'm going to do is I'm going to draw out a little sketch. So here I've drawn our cubic function, and I've also put in our local minimum point at 0, 5. So local minimum point basically means the turning point when the function goes from decreasing to increasing. So let's just say we take a random point, which is this point here, and we'll say that this point here will be -2, 1. Well, looking at h of 0 is going to give us 5, but if we take this random point down here and we say that h of -2 will be equal to 1, you can see here that 1 is clearly less than 5, so therefore this statement must be false. And the reason for that is, what we just proven, is that there could be other values for x which give us points below 5, because as you can see here, the value of -2 for x will give us a point of 1, which is obviously below 5. So I've just written down our justification there, and to prove that answer to be false, you get a total of 10 marks. So that concludes the question, guys. Hopefully it's all a bit easier now, and thanks very much for watching.